Good morning, everybody. My name is Omar Cardona. I am a professor in the National University of Colombia in Manizales. I'm going to be the chairman of this session on Capra, measuring the measurable. And we expect to have a very interesting presentations and discussions, and of course questions of all of you. First of all, I would like to present my apologies because it was not possible for me to be in the Ignite presentation because the aerial space of Washington was closed yesterday all afternoon. But anyway, I am very grateful with Professor Luis Jamin that presented the Ignite yesterday in the evening. Okay, Capra means risk assessment. Risk assessment means the hazard evaluation, its convolution with vulnerability of exposure, and of course the risk assessment itself. Then we decided to develop three presentations that will be developed. The first one about the multi-hazard approach by Gabriel Bernal. Gabriel Bernal is a senior engineer of UR2010 Latin America and in the University of Los Andes in Bogota. After this, we will have the presentation about the exposure and vulnerability by the Professor Luis Jamin from the Los Andes University in Bogota. And the last presentation will be by the Dr. Eduardo Reynoso from the National Autonomous University of Mexico and UR2010 about the risk assessment. After this, we will have three discussants that will be Vanessa Rosales from the Comisión de Prevención de Riesgos y Atención de Emergencias from Costa Rica, José Ángel Villalobos from the Instituto Nacional de Seguros of Costa Rica, and the last discussant will be Ernesto Durán from Sistema Nacional de Estudios Territoriales ESNET El Salvador. After this discussions, presentations or comments, we will an open session of Q&A. And then for this, I request all of you please to write the questions. Our colleagues with the orange shirts will give us these questions, and we will have a panel at the end of this session with all your questions and comments. Okay, so to understand risks and to start with this session, I give the floor to Gabriel Bernal of Los Andes University to talk about the multi-hazard approach of Capra. Thank you, Gabriel.
Thank you, Omar. Well, good morning to everyone. This is the multi-hazard approach in Capra. First, I would like to refer to the risk analysis methodology, which combines hazard, exposure, and vulnerability in order to assess physical damage, estimate loss in economic and human terms, and use those risk results in specific applications of risk management. In this presentation, I'm going to talk only about the first component of the risk analysis methodology, which is hazard. Well, Capra implements a multi-hazard approach based on triggering events. First of all, there's a primary hazard, such as earthquake, rainfall, hurricane, and volcano, which generate certain effects over the region. These effects are related to ground shaking, precipitation, wind speed, storm surge run-up, lava flows, pyroclastic flows, or ash fallouts. These effects may generate secondary hazards, may trigger secondary hazards. For example, ground shaking triggers tsunami and landslide, and precipitation triggers landslide and flood. These secondary hazards also generate certain effects over the region. Secondary hazard effects such as run-up height for tsunami, slope instability, and flood depth. Now, all of these effects have physical measures and are computed in a way that allows them to be plugged directly into the Capra risk analysis module, which is called Capra GIS. How do we plug this information, these hazard results, into Capra GIS? It's a question we needed to answer under the development of Capra. And what was done was the development of a standardized representation of hazard. In Capra, hazard is represented as a set of stochastic scenarios. This set of stochastic scenarios are mutually exclusive, collectively exhaustive. They may account for historical events, but most of them are simulated events that haven't occurred yet. And they all allow a probabilistic representation. So each one of the scenarios of the set may have several intensity measures, which is specifically useful in seismic hazard analysis, where peak and spectral intensities are computed. Statistical moments, so that the hazard result is not an intensity value, but an intensity probability distribution. And finally, an annual occurrence frequency that takes account of the fact that larger and highly destructive events occur less frequently. What I'm showing here is the seismic hazard result for Latin America and the Caribbean. Those red dots you see on the map are simulated earthquakes. This result has a total of 145,980 simulated earthquakes, each one with 23 different intensity measures related to the structural vibration periods you see right there on the table. All this information is saved into a NAME format, which is the computational format developed for Capra for hazard saving and plugging into risk analysis. Also, we can develop equal return period maps, hazard maps, with Capra, performing a hazard integration over the set of stochastic scenarios. Hazard integration is ruled by this simple equation that states that the intensity exceedance rate, which is the number of number of events over a year, the number of times over a year that an intensity value is reached or exceeded. Please note that this quantity is inverse to the return period. Is computed as the sum for all scenarios of the exceedance probability of an intensity value conditional to the scenario occurrence times the scenario annual frequency. That's it. If we perform the hazard integration in each computation site, we can get a hazard curve, an intensity exceedance curve, that relates intensity measure and exceedance rate. Now, in order to develop hazard maps for several return periods, it's as simple as going into each computation site and cutting this curve at the corresponding exceedance rate value, like this. You cut the curve, read the intensity value, and map the result. Now, all this is done using several open source software tools developed for Capra that run probabilistic models for each type of hazard and save the results on the corresponding AME format to be used in risk analysis in Capra GIS. Now I'm going to show you some chosen results of hazard analysis for Latin American countries done with these software tools. For seismic hazard, here we have Peru, seismic hazard of Peru. What you're seeing on the map is peak ground acceleration for different return periods. This is 250 years return period, 500 years, 1,000, 2,500, and 5,000 years return period, done with the Capra hazard tools. For tsunami hazard, this is Costa Rica, a national level analysis of run-up height on the Pacific coast of Costa Rica. The scale is in meters, and here we have also different return period maps, 100 years, 500, and 1,000 years. At a local level, the analysis can be performed also in different scales. This is the city of Puerto Quepos in Costa Rica, in its Pacific coast. And what you're seeing here is the tsunami run-up height for 500 years return period. For hurricane hazard, here are some results for Honduras. This is top wind speed in kilometers by hour for 100 years return period, 500 years, and 1,000 years. And here I'd like to show the result of one simulation of Hurricane Mitch. What you see on the map is the mean value of wind speed for 100 simulations over Mitch's original path. That can be done also with the Capra hazard tools. Rainfall. This is the city of Bogota in Colombia. What you're going to see here are some stochastic storms generated with the Capra hazard tools. The scale is in rainfall precipitation millimeters. And the stochastic storms, you see how the shape changes. This is the kind of scenarios that are saved into the AME file. Flood hazard. Here I'm going to show you a flooding hazard analysis for a Hurricane Felix simulation at Calico River in the municipality of San Dionisio in Nicaragua. What you see in the video is the hazard being computed with the Capra flooding software tool. And here is the final analysis for that scenario. Landslide hazard. These are some results for Guatemala using an infinite slope analysis methodology. What you see on the map is the inverse of the safety factor. This map you're seeing is for a dry soil condition and no earthquake. Here we have a wet soil condition, no earthquake. Dry soil condition and a 6.8 moment magnitude earthquake. And wet soil condition and a 6.8 moment magnitude earthquake. And finally, volcanic hazard. This is the city of San Salvador in El Salvador, and this is the San Salvador volcano near the city. What you're seeing here is the area feasible to be affected by lava flows. Here is the area feasible to be affected by pyroclastic flows, and finally, the ash thickness in meters. The scale is in meters for a BEI for eruption at San Salvador volcano. BEI stands for Volcanic Explosivity Index. And that's it. This is the hazard module of Capra. The next presentations will talk about exposure, vulnerability, and the risk assessment itself. Thank you very much.
Thank you, Gabriel. Now, as Gabriel said, it's necessary to see the other side of the orange. is the exposure and vulnerability, because usually we have good information for hazards, but it's necessary also to have very good information about exposure and particularly about vulnerability. So, Professor Luis Yamin from Los Andes University, I give the floor.
Well, good morning. I'm going to present the exposure and vulnerability models of the Capra platform. So we divided the main information for the analysis in these three main categories. I'm going to talk first about exposure and then about vulnerability. The next talk will deal with the integration of all this information in order to get physical damage and other additional applications. So what do we mean by exposure? First of all, we have to identify and characterize the critical assets that are susceptible of suffering any type of damage or consequence due to the hazard we are trying to consider. In that, we have to identify mainly these main components of cities, urban buildings and infrastructure. We also would like to identify rural constructions as well as regional and national infrastructure. And in addition, we will also have to identify the human exposure to these potential effects of the different type of hazards considered. In terms of components at risk, for cities, we need to identify clearly what type of buildings we have at different locations of these important cities that we are trying to analyze. In terms of buildings, we in addition have to identify what type of use those buildings have in general, and we have a general classification such as residential, commercial, industrial, health, educational, governmental, and other types of buildings. In industrial areas, we also need to identify each one of the components. When we are dealing with hazards, each one of these components may have a different behavior when they are subjected to any one of the intensities of the different type of hazards considered. So it's not an easy task to do when you have these very complex situations. So we need to characterize each component and perform a vulnerability analysis, as we'll show later. In terms of water production and treatment and distribution system, is the same. There are a lot of set of different type of components that should be analyzed and considered. The same thing with the communication system, where we have roads, bridges, tunnels, all of them behaving different to the different type of hazard input. And finally, electrical generation systems, hydroelectric generation systems, and electric distribution systems, and finally communication systems. So what is the minimum information that we really know? Exactly the minimum, because here we have a very big problem of information. We need a general ID. We need, of course, the geographical location in order to match to the hazard distribution. We need the construction type for vulnerability classification, and in this case, what we usually have is specific information on characteristics of the main components. We also need an exposed economic value, and if we want to analyze the human consequences, we of course need the human occupation. For this case, so we decided to use shapefiles as a standard information for exposure. Shapefiles in the form of polygons, lines, or dots. So here are some illustrations about the resolution that we can use in the different type of analysis. For example, at the city level, we can use a building by building resolution, so we have information for each specific building in the city. Or we can group this information into the bigger scale using, for example, blocks, or maybe neighborhoods, or different. This is like an administrative zonation of the city of Bogota, or even we can use localities or towns. So the user has to clearly define what is the resolution he wants to use for the exposure information. It depends on the amount of information available and on the final application of their results in relation to the risk applications, as we will see later. At the country level, we can have more or less the same thing. We can perform analysis at the global country levels in, for example, the idea of comparing different countries in terms of risk analysis, or we can get down to lower scales such as departments, municipalities, or even towns, localities, neighborhoods, etc. The ideal thing is to have specific information at the building by building level, and this is the typical information that is usually available in the information for cities, such as socioeconomic level, number of stories, or cadastral values. These are very important piece of information that we can include in the analysis. But in general, with no information available, so we need to generate different type of tools that allow us to complete this information. We need the geographic coordinates, and in general we need to specify some general characteristics of each one of those components. So Capra includes a set of different modules that are very easy to use. They are open source and really available for anyone to use it. As for example, this is Capra Info Punto. It's used mainly to identify for each one of these buildings here a set of information that could be included into the database in order to begin to build a complete city or zone of analysis in this way. We can also use mobile phones with the standard methodologies already developed in order with GPS. So in general we use students, we train them, and we send them all around the city with these mobile phones, taking pictures of the buildings and locating with the geographical location and giving the basic information that you can obtain from just a visual inspection of the city. And these are some of the results. This is an example for an insurance company in Cartagena, Colombia, where we just go to each one of the buildings that we had to be analyzed, and we get the information and we put all them together into a database for future information and consultation. We also have a routine for polygons where we can input the information of each one of the buildings with the exact shape, looking this from an aerial photography, and we can complement as well the information that we can from the figure from the photography. We can just interpret, for example, the number of story, the type of roof, the type of building, etc. With this type of information, we begin to build like virtual cities, one by one, with a lot of people working here, and at the end we can have a complete city built up with this type of information. This is an example for Managua, Nicaragua, where we have a building by building model. You see here each one of the buildings digitized according to the previous methodology, and this is the general overview of the city once we have all the buildings included into the database. These are other examples. This is blue fields from Nicaragua in a building by building basis as well. This is Corinto, Nicaragua. Very difficult place to be here, no? This is the sea and this is the river. We have San Juan del Sur, we have Punta Arenas. We can also use this module to include information for infrastructure. For example, this is a port, specific port in Kingston, Jamaica. So you can measure the length and the general dimensions of the port and the different type of buildings included in the port, or even for the airport, the same type of information. And you can build as well virtual models of big cities. In this case, San Jose, we didn't have the specific information building by building, so we decided to develop a simplified model for homogeneous zones. In each one of these zones, we will have specific parameters to define. For example, this is the zonation we decided to do at the end, And for each one of these zones, we will have an estimated total number of buildings, a total construction area for each one, the total exposed economic value, and a relative distribution of construction types for each one of these zones. So we build up like a virtual city. One of these is a virtual building located approximately between the homogeneous zone, but with all parameters within the homogeneous zone according to the information that we already had available. After that, we can visualize these controlling parameters such as structural type, the replacement value for each building, the human occupation, and so on. So the idea is to build virtual cities like in a 2D dimension or 3D dimension, or even having a complete city like in this case in Bogota, where we have very good information in a building by building basis. Of course, they are very, very rough models of the buildings, but we have with this a very good information for a general risk analysis procedure. If we don't have specific information, we can also use exposure indicators as the one shown here, for example, for different types of cities. Depending on the socioeconomic level, we can do some estimates about the construction area per capita or the total value per square meter for these different type of socioeconomic constructions within the city. Or we can also have this type of numbers here for different type of cities considering their size and population, how much is more or less the amount, the money per capita for each one of these infrastructure systems within the urban area of the city. And in general, what we build up is a general exposure database like this one. At the end, it comes out to be very simple information. As I mentioned, the ID, the geographical coordinates, construction type, exposed value, and human occupation. This is an illustration of one of the standard databases that we use for the analysis. Next, our job is to define the vulnerability curve for each one of the components. The vulnerability representations relates any type of hazard intensity. As Gabriel mentioned before, we have to define for each hazard which is the main parameter that would be better interpret the damage of each one of the components. So we will have different type of parameters here. As we mentioned, the earthquake can have a lot of parameters, not just the acceleration as we usually use it, but we could also have the displacement or the velocity, etc. And we will have different parameters for other earthquake scenarios. And this vulnerability curve will relate this intensity of the hazard with damage, mean damage radio in general, with, of course, the consideration of the variation of each one of these specific values. So we come out with a general classification of construction types. This is mainly oriented for Central and South American countries, where we define typical constructions such as unreinforced masonry, confined masonry, adobe and quincha. This is typical historic houses and buildings all around Central and South America. We can have also reinforced concrete frames, not always behaving as good as we would like. We will have high-rise steel buildings or concrete buildings in big cities. We will have, of course, wood structures, and non-engineered construction. That is one of the biggest problems in these cities, where usually more than 50% or something like that of a city could be built with this type of non-engineered construction with specific vulnerability behavior. So different vulnerability methodologies have been developed in order to define these vulnerability functions or curves. We have used both analytical and experimental methodologies. In this case, for example, these are buildings that are mainly sensitive to the drift of the building in order to estimate the damage. So in the experimental area, we can build models in the laboratory in order to adequately measure what is really happening with this type of buildings. We can also have analytical procedures for this type of buildings where we can identify the critical regions, the zones where these buildings will be more affected by specific hazard scenarios. And we will have here some illustrations of experimental procedure. For example, this is an adobe house, one story. This is just the final test for collapse. Or even this one. This is a 2-floor scale model subjected to specific earthquake simulation in order to determine the parameters for the final collapse mechanism. So we build up like a library of functions, vulnerability functions, that the user can easily select depending on the type of component that they are analyzing. And we have, of course, a set of typical vulnerability curve for different hazard scenarios: earthquake, wind, floods, and others. Finally, what we have to do is, if we don't have a detailed information, we have to define a microzonation of each one of the cities. This is for Lima, Peru, where we identify for each zone the typical type of construction, the relative distribution of each one of these type of constructions, in order to have complete the analysis, the information required for exposure and vulnerability. Thank you very much.
Thank you, Luis. We will have the opportunity for the questions after, in the end of the session. And now we need to pass to give the floor to the Dr. Eduardo Reynoso in order to present the risk modeling and the module related with risk assessment that is very important to the convolution of hazard and vulnerability. So, Eduardo, thank you very much.
Thank you. A lot of you know that building a model, a reliable and probabilistic model that formally computes risk and is useful, takes a lot of time, takes a long-lasting effort, and a lot of people. So I would like to thank people that never comes to these conferences because someone has to work, you know. But they are in Mexico, Colombia, and Spain, and a lot of places doing this type of very demanding job. And also I would like to thank our clients that they push us to the limit, and sometimes we get challenged by them, especially people from the World Bank that has been very committed and very enthusiastic on these projects. Okay, so there are many challenges and limitations of formal probabilistic risk model. Like most catastrophic events have not occurred yet. We have seen this year a lot of events that we didn't expect. We don't have historical data or very little information. We have, and it's a problem of the people, very short memory of previous disasters. Short time data gathering window for modeling hazard events for long recurrence periods. We don't have information of tsunamis and sometimes earthquakes or floods. And the information of floods changes if you build a dam, it changes everything. Or it moves the problem to another place. We have to simplify the hazard modeling, but the problem is very complex. The modeling process requires experience and common sense. And finally, computers are not as fast as we would like to. So we have to simplify some things because of limitations in computing. Well, we have seen this plot, so I will go fast. What I'm going to do now is talk about these applications, taking into account that we know the hazard and the vulnerability. So we have some results of loss estimation that needs to be done by all possible scenarios or one single scenario, depends on the application. And we can compute now results in terms of economic losses or percentage of losses or even fatalities. This is the whole process of the computation of risk. For each hazard, we have many hazards as we saw. And for each hazard, we have to do a lot of scenarios, and then for each portfolio, we have to compute for each component of the portfolio, and we can obtain many results. Could be PMLs or, as I said, human casualties. And this was already given in the hazard talk. I just want to remember that if we want to compute losses for earthquake, we have to take into account that possibly there is a tsunami after the earthquake, and also it can cause landslides, and also for hurricane and other hazards. Just one slide of mathematics. It's not an idea to show the mathematics, but at least allow me one slide. Just to show you the complexity of the problem, we have to compute for all vulnerability functions and for all the hazards, we have to compute this equation, and then we need to compute the return period of the losses, which is including all the events of every hazard. So this really takes a lot of time. For some hazards, we have like simplified the problem, which in a good sense, but for other hazards like flood and among others, it's very difficult to do all the events and run all the sets just because of the time. Okay. This is one very useful result of this formal computation of losses. This is mainly used by the insurance companies and the insurance sector in general, but it's also used for the governments, or if you own a portfolio of many buildings, you can see the losses in terms of return period here, and what is called the PML. PML, we don't like the definition, but it's very, you can hear that word or words in many ways, but the term maximum is relative. So for one, maximum it's a very large thing, but for the other may not. This is used now by at least the Mexican government and the government from Peru to regulate insurance companies, and they say that the maximum, the government says that the maximum is 1,500 years, but for insurance companies they say that this maximum is too high. So the very definition of maximum is not a standard. They say, the insurance companies say that 500 years would be fine. So it's PML. It's a very common result, a risk result, but it does not have a large definition. What we say is that we provide a tool that computes everything. So it's just for others to decide which is the best way to interact. We were attempting to show results for Mexico and Colombia and other countries where we have been working very hard with the government. But because of the time, we were going to show just some results for Capra. And here I would like to thank the Central American governments for understanding us and providing us the information. Sometimes it's not easy to get the information, but anyway, it's something that we have to work together for a long time. Just an example of a deterministic scenario for Nicaragua, and this is a risk result in terms of economic losses for the whole city of Managua, but also for individual buildings that, as was told in the previous presentations, we have all the information to obtain these results. For Costa Rica also we can plot results by regions. These are also in terms of millions of US dollars. For the city of San Jose, we can group that results in other regions, as Luis told. Here we have a percentage of losses. Also, we can group that by county, by zip code, and plot and certain result for a given return period, let's say, in this case, 500 years. So decision makers can take all these results and try to do something. Many things can be done with these results. Human expected life losses. For El Salvador, I want to show these curves of return period and PML, and this is for public buildings, so they have an idea of how much they can lose for a given scenario or a return period for this type of buildings. Another result for production and distribution of energy, so the energy industry. Here, the shape of the curve is different, of course. Also for roads and highways, which is very difficult to assess because there are so many hazards involved in this. Then for the city of San Salvador, and you can put that together in a Google map, which is very, very useful. We have found that although we've been working with this risk result for many, many years, doing these PML versus return period curves and tables and all that, when a decision maker sees a map like this, it really, really helps. So maps are really what should be put into decision making. Of course, you have to rely on tables and results, but maps are really, really useful to understand risk. Everyone can notice that these red zones are related to high risk. Another view of San Salvador, economic losses, which is not the same compared to relative losses. Then the city of Bluefields in Nicaragua. We can see here wind loss in terms of percentage. Zoom to those places where we can see here which are the buildings that are the largest risk. Human losses, of course, we cannot expect a lot of human losses due to wind. So these yellow shapes are really, well, are zero losses. Just some buildings where the model says that we are expecting some losses there. Storm surge for Bluefields. Well, it's not very clear, but there are some reds here and oranges here at these places very near the sea. Losses due to storm surge. And also for the city of Corinto in Nicaragua, we can see the losses, the expected losses due to wind and due to storm surge. We would like, seeing a city like this, wind loss could be large, but also we could expect in terms of also in percentage, and we can do a zoom here to see which buildings are at the highest risk. And due to wind risk, human expected losses, very few, just in some specific buildings. And finally, we can see that for this scenario or this return period, and for this city of Corinto, we cannot expect damage due to storm surge, either in percentage or in economic losses or human life losses, which is very good. I mean, it's good to know that for some scenarios and some combination of hazards, not always we will expect damage, at least for the information that we have at this moment. We will learn some things in the future, we know that. We've been learning every time. Okay, thank you.
Thank you, Eduardo. Please remember that we need your questions if you have questions in this type of piece of paper, and we will have the opportunity to collect these questions for the speakers. Okay, I would like to say that Capra has been an initiative developed in Central American countries, now with the possibility to apply in some countries of South America. And this is very important to know what is the thinking of some of our users. This initiative was supported from financial point of view by the World Bank and the Inter-American Development Bank. We have Capra in Nicaragua, in Costa Rica, in El Salvador, Belize, Guatemala, Honduras. And then this has been a very interesting process in the last 2 years. So now we will have 3 discussions. The first discussion is the president of the Commission, the National Commission of Prevention and Risk and Emergency Attention of Costa Rica, Mrs. Vanessa Rosales. So please, would you like to make a comment about how has been Capra in Costa Rica with you, that is the main stakeholder of Costa Rica of this type of tools? Thank you, Vanessa.
Well, thank you so much for letting me share some of our experiences regarding the use of Capra. First of all, I have to say that last year we finally made a consultation process among many institutions and representatives of the private sector and the communities, and we came out with a national risk management plan for the year 2010-2015. And this is a really good base for a frame for the use of Capra in several initiatives. The new government is preparing the National Development Plan for the next 4 years. And since now we have a risk management plan, then the conditions are ideal and we might include risk management on the new development plan. So far there has been a very satisfactory institutional commitment towards Capra. One of the best examples is the project that the Water and Sewage Institute is leading and is using the seismicity module of Capra in a project for risk assessment of the water and sanitation systems in the capital city of San Jose as well as in rural communities. With support from the World Bank, and there are many other institutions participating, such as the Faculty of Geology of the University of Costa Rica, Institute of Electricity, and many technical institutions, and also support from other countries as Mexico and Colombia. Among other experiences, there is a project based in the use of Capra to estimate seismic risk. Luis and the other speaker already mentioned that, in the capital city of San Jose. Several institutions are participating, and all of them are members of a very special coordination instance that we call the CATs, the CAT, which are the advisory technical committees. And this specific one is the engineering risk CAT, and the members of this CAT are, among others, of course, the institution I represent, and also the National Insurance Institute, Seismic Code Permanent Commission, and many others. And in this project, they are using Capra for hazard analysis, property inventory, estimation of vulnerability, and finally, the estimation of risk. And the good thing about this project is that it's a good example of innovative partnerships, and even UNDP is also funding a part of the project, and the municipality of San Jose is also involved. So this project really requires a lot of intense in this interdisciplinary and interinstitutional participation. But so far, the good part of having also a hazard analysis basis coming from the Norway project RESIS 2. So we have the scenarios, now we have the institutions, we have the commitment, and we hope to have really good results in the short term. And there are other proposed uses for Capra in flood research, also in volcanic eruptions. We have 3 very active volcanoes lately, and landslides. What we have as a strength, probably as a country, is our Organization for Risk Management. And we really believe in these coordination instances we call the CATs, because they allow the strengthening of a national multidisciplinary approach to risk calculations, and of course they become the ideal foundation for the use of Capra. Some of our CATs are, for example, seismology and volcanology, hydrometeorology and rivers, marine coastal, and many others. And any initiative of the intention of use of Capra has to go to a CAT, to a CAT, and be discussed there and approved. And of course, we as a leading institution, we follow up. We, as a country, do not want Capra just as academic exercise. What we want is the use of Capra for decision-making processes, for land use, emergency information management, and of course the strengthening of the national system for public investment. And I brought, and this is just came off the press, our planning minister, the last one and now the new one as well, developed, working with us, a methodological guide for identification, formulation, and evaluation of projects for public investment in Costa Rica. And it has a very detailed chapter on disaster risk, they call it that way. But in the annex, they have a lot of tables and the use of indexes for determining the evaluation of a project before deciding to do the investment. And what we see that this is a very good example of what Capra could reinforce and strengthen and even make it more powerful for decision making. So if anyone wants to take a look at this, I would gladly share it with you. And thank you very much for the opportunity.
Thank you, Vanessa. Now I would like to give the floor to José Ángel Villalobos from the Instituto Nacional de Seguros of Costa Rica. Please, José Ángel, your impressions about our work in the last 2 years with you. Thank you.
Thank you. Good morning. Well, for us, as an insurance company, Capra has been an opportunity to have access to a technical transparent model and even it also has given opportunity to put together some local knowledge. There is another project called Resist 2. There is a book about the results and they are put into the model. So as an insurance company, it is helping us to determine capital requirements, to determine pure premiums and PMLs, and to construct a special vehicle for catastrophic transfer. Maybe that's it. Thank you.
Thank you, José Ángel. Now I would like to give the floor to Ernesto Durán from the Sistema Nacional de Estudios Territoriales SNET of El Salvador. Thank you, Ernesto.
Good morning, and thank you very much for the opportunity to share our experience working with the project of Capra in the last 2 years. I'm going to walk over the footprints of the project, telling that we have been working with the experts of ERN, World Bank, AIDB, but also with some of the colleagues from El Salvador, trying to understand and to apply what is coming from this platform. After these 2 years, very easy to see that it's becoming progressively a useful tool for decision making. But especially when through this process we can consolidate, building up methodologies for hazard and risk evaluation and assessment, but mainly its purpose to raising risk management awareness at different territorial and sectoral levels. Talking to some colleagues back in El Salvador, we have found and underlined some of the advantages, some pros, when using this Capra as a tool for risk management. When we see this modular, we can go through the three modular type of analysis: hazard, vulnerability, and exposure, and we can use it, but we can do it extensible if we need it and if we have the capacity to do it. But also, as an open source, it brings advantage over our communities, over our technicians in order to use it. This facilitates its access and sustainability. But besides its wide application in risk analysis, risk management, land use, cost-benefit analysis, which is a good tool to talk to the politics, we also found that it is a great tool to identify prevention and mitigation actions. But we found that this is a process where we have to go in, and even if we have been working the last 2 years, we see as a capacity building as an opportunity to increase our capacity to do this analysis and to use it as a tool in the development and risk analysis. We have tried to enroll different community of users in order to bring people to understand risk, not only the community of specialists in risk assessment, if not people coming from NGOs, universities, government, and the private sector. But especially this is important because it will promise for us a sustainable application by building up institutional partnership for the future. So far we have worked and we have reviewed and knowledge the baselines of architecture for the hazard and vulnerability modules of Capra and its application of the hazard models for hurricane, flood, windstorm, storm surge, earthquake, landslides, tsunamis, and volcano activity, which were proposed and explained in the second workshop that we just have in the last April. This was shared with the technical counterparts, and we saw this as a great opportunity to go over the second phase of the analysis, to see if the loss estimation, if the economic losses that we share in this workshop, that the production and distribution of energy, human losses, can be the information that we need in order to take decisions at the national and the local level. Still, asset data collection remains the central challenge to this initiative, even for us as technicians, but also assessment of vulnerability and risk at the appropriate resolution and scale. Even if intensive coordination efforts are made, it suggests on one hand the need of building of a spatial and statistic national infrastructure with open and public access in order to have the data and information available when we need to do the analysis. But also the adoption of this tool with the participation of different actors in order to go to the local level. We just have the impact of the Agatha tropical storm, and even if we take decision about at the national level, we know that we have to progress, we have to advance at the local level. So this is where local efforts should concentrate in order to use Capra as a tool, as a provider of a common methodology for assessing disaster risk by setting the necessary standards and providing a quantitative measurement of physical, economic, and human loss in order to reduce its impact during the events that impact our country. Thank you very much.
Thank you, Ernesto. Now I would like to invite the speakers and the discussants to this forum to end the session. I have now a set of questions, and so I'm going to make the questions according with my feeling who could be the better person for the answer. So to start, I have this question for Dr. Eduardo Reynoso. Have you validated the Capra models, simulations, with any real event, any recent event like Haiti or Chile?
Well, all the models have been calibrated with historical events. Well, I said in my presentation that we have very little information on that. But for instance, Managua was calibrated for the Managua earthquake, which happened in 1972-6, and so on. With recent events, we haven't done that yet. For instance, for Chile, we are still waiting for the data. Chileans are really busy on fixing the buildings and assessing the losses. So we are still waiting for them to give us some information so we can calibrate our model. And for Mexico, we had this earthquake in Mexicali. It was this year. It was a very strong earthquake with a lot of damage, no casualties, but damage. And we, at that time, the very day of the earthquake, we sent a message to the insurance company saying that the expected losses were whatever, a number. And they are going to be very similar. So as far as we know, what the insurance companies have been computing is going to be very similar to what we, at that time, or what our models have. So every effort to assess and to calibrate the models is very welcome, but it's not easy to do that. And sometimes the gathering of the information is not as reliable as we need it. So we are doing that, but not as much as we would like to.
Okay, thank you, Eduardo. Now I have a question for Professor Luis Yamin. Regarding the exposure model, do you have the opportunity to compare these virtual cities with the real data based on, for instance, census data? How are the results?
The answer is yes, of course. The census information is very important. However, we would like to have the cadastral information. This is the real piece of information that we will like to have in order to really calibrate the model. But with the census information, we have the opportunity to compare in different cities, such as Mexico, Bogota, Managua, and other cities, San Jose, Costa Rica. Mainly big cities, no small cities or small towns. They don't really have any type of information, and in those cases we have to do it the job house by house, building by building, and using other methodologies. But certainly the exposure model has to be calibrated at least with the census information, and preferably with the cadastral information if available.
Okay, thank you, Luis. Now this question for Gabriel Bernal. When you say that computing all the scenarios, complex ones, takes too much time, what kind of software and hardware are you using? How many scenarios? How many hours? does it take to run each one? Are you using map-reduce strategies or more traditional computation methods?
Well, the software tools we developed are developed on .NET Visual Basic Language, and they run on any Windows-based computer. The calculation time is it's a very good question. A few days ago, we were running a catastrophic risk analysis for Mexico, for municipality exposure points, with about 30,000 records on the exposure database and about 60,000 scenarios of earthquake hazard. And it took kind of 30 hours to complete the entire analysis. So that's the best indicator of computation time I can give you. About the tool that you mentioned in the question, what's the last part of the question, please?
Well, now it's a big problem for me because I am not exactly.
That's fine. We're not using that tool. Don't remember the name, but we're not using that. We're not using different or available GIS modules or libraries that one can download from the internet or something like that. All of the software pieces were developed by the group.
Okay. Thank you, Gabriel. Now a question for Dr. Reynoso. I'm going to make two because I know the first response. I would like to know if fire following earthquakes as secondary hazard is under consideration. But for Eduardo again, what are the challenges in replicating Capra in low-income countries at high risk? For example, Haiti. How does it link to the ongoing Haiti multi-hazard assessment?
Okay, the first one, which is the fire following an earthquake, for us it's very clear that we haven't seen that in our cities in Latin America. Maybe it's because we don't have such large housing made of wood. So none of the recent earthquakes in Latin America has produced a fire in a city. In Mexico City there was one, but it was related to a very specific building which had a restaurant downstairs. It was a very local thing. But it's not a problem in any city as far as we know. That's why we haven't considered that. We had to do other things that in our models, but not this one. And talking about IT, I was talking to Sergio, with Sergio, and he was mentioning something in his presentation this morning, that we can do many things with IT, but we need to wait and we need to be asked by them. Otherwise, they won't work. And at least what they are doing now is putting everything in a GeoNode, which is very good. And so the information is going to be there for everyone or for many things. And of course, we can do a Capra project for them, especially if they are going to move the capital city. We need to know which is the best place to put the city, so we have to do earthquake models, flood, tsunami models, and all that. But a lot of us are waiting for them to be organized or to ask. We all know that their priority is not this. Is not to plan, is to really move to the next step. But many things can be done with IT. Supported by the World Bank, and it's very easy, I think.
Thank you, Eduardo. This is for Professor Yamin. How is the group thinking about the multi-hazard simplification when portfolios and hazard characteristics are so different?
If I understand the question, The problem is how we can combine the results coming from different type of hazards and different type of elements exposed. So the answer is quite simple. The final results of each risk analysis can be either the expected loss, economic loss, or the expected human effects, loss of life or injuries or whatever. So these two figures can be added up independently of the type of hazard or the type of vulnerability component. So I think this is the question, if that was the question. So we just have to add up the result, for example, of the expected annual loss of each one of the component for each one of the different type of hazards considered. And in this way we can come up with the total global sum of expected annual loss for the portfolio for each scenario, and we can, like this, sum up all the scenarios as well.
Okay, thank you, Luis. Now for Gabriel, I have two questions of Tony. You did not mention storm surge and waves, which are very destructive. Why? But indeed, we mentioned. But the other one maybe is interesting to explain maybe the characteristics of the map of Honduras. Your mine hazard map for Honduras suggests an uniform hazard across the whole country. Why have you done this when it is well known that the wind speeds reduce rapidly as the hurricane crosses the land?
Okay, for the first one, as I said on the presentation, the effects for the hurricane hazard are precipitation, wind speed, and storm surge. Those are the effects that can be calculated using the hurricane hazard tool. And for the second question, there is in fact a decrease on the intensity level of the wind speed. I believe I didn't choose the color scale properly, and the map showed a same color, but actually there's a decrease from the shore to inland. And also I would like to add that it is a map of an equal return period, which considers a large number of scenarios. Some were historical scenarios and some are simulated. Most of them are simulated scenarios. And when you perform the hazard integration analysis, it tends to smooth the intensity over the analysis region. But it clearly decreases from the shoreline to inland.
Okay, thank you, Gabriel. Now for Dr. Reynoso, how are the products of Capra made available to the private sector?
Well, they're going to be available for everyone. So I wonder if this is related to the insurance models, insurance companies' models. But I mean, I can think as an example of a book. If you publish a book, no one is allowed to publish it again. I mean, Capra is published there, is available, but I wonder if it can be used by others to build another Capra by their own. But if you own a building in, let's say, San Jose, you can use Capra to assess the risk, even if it is your own building. I don't know which was the sense of the question, but I think that I covered.
You can say something about, has Capra influenced private sector investment in disaster risk reduction?
Not yet. But the idea is, I don't know, but I don't think so. It's too early for that. But the idea is to go that far.
Okay, thank you, Eduardo. Now, Dr. Yamin, in characterizing buildings for earthquake damage prediction, how do factor in things like shortness of construction, failure to meet building codes, and the like? In other words, how do you go from theory to reality?
Yes, this is really a difficult question, but what we have done is just we are, as I show, we are calculating different vulnerability curve for different type of constructions, and for each, even for each type of construction, we even consider different type of quality of constructions, or let's say like code compliance of each construction. So we have different degree of quality in each type of construction. So I think this is not, this is as I show, analytical or experimental results, so we have the curves there, but the difficult thing to do is to take and to choose which curve do I have to apply to each type of component. And in this case, we really have to do a difficult job, is to, with the general characteristic of the buildings, the age of construction, the location, the type of building, the materials they use depending on the year of construction, we have to actually try to predict what type of behavior will that building have in case of the event. So in that case, I think it is required the participation of an expert, of an earthquake engineer, a structural engineer with experience, with knowledge of the city, of the type of buildings, of the history of the city. So of course we need to get to the local people in each city in order to make this match of buildings to different type of vulnerability curves.
Okay. Thank you, Luis. Now for Dr. Reynoso, just a very interesting question. Hazard and risk maps are good tools to communicate risk to decision makers for decision making and planning. My question is, do you provide for communication of uncertainty associated to risk outputs such as maps, and how do you effectively communicate this uncertainty? Eduardo.
Yeah, that's a tough one, because we haven't found a way to communicate risk. It's a very difficult way. The concepts are really, really hard to understand, are not obvious. It's difficult. So eventually we have to move there, working with people from the social fields, from the experts of education and communication. We are, as engineers, are not very good doing that. We are trying, but I think that we have to go farther than that and think differently and really look into this problem, because it is a problem. How to communicate the uncertainties and all. Insurance companies have some experience with this. Yeah, we haven't done that as it should.
Okay, we have time to make a question for all of you. I think all of you can make a contribution to make this a response to this question. Is Capra used to identify options for countermeasures or mitigation? And I think this is the question. Finally, risk assessment is for disaster risk management, decision making and management. But all of you, I would like to start with Ernesto. Is Capra used to identify options for countermeasures or mitigation?
Yes. After finishing the analysis of hazard, exposure and vulnerability, what we have found is that the result of the analysis give us the opportunity to contribute to land use, territorial management, which have included measurements to mitigate risk at different territorial levels, but also experience such as one that the University of José Simeón Cañas, UCA, has in a small community using Capra, tell us that the platform, the tool, it's useful to identify specific measures that contribute to mitigate risk and reduce disaster impacts. As government, what we are waiting is the result of the risk analysis, which is missing in our process in El Salvador. After we will have the third workshop, I guess we will have the complete analysis, and we have more clear that which kind of measures we're going to be able to take in order to reduce risk in those places where we have worked in the last 2 years. By instance, working with Aguachapan, San Salvador, and Izalco, La Libertad, we have seen so many opportunities to propose mitigation measures, but we still wait in order to have the complete scenario in order not to fail in our intervention with the locals, but also with the national government, NGOs, and private sector.
Thank you, Ernesto.
I think so. We are working at the national level, and we have already developed a specific vehicle for transfer of catastrophe risk for the government of Costa Rica. So this can be seen not as a simple counter effects. Capra can be used as a tool for the risk management. It can be used to quantify the risk in terms of economic or in terms more important human lives. So the answer is yes, but it should be seen something a little more ample.
Well, I think yes, but not yet. Probably we are as a country waiting for more precise results and identification of specific zones or specific areas where we could take some particular mitigation measures. However, so far it's very promising, as the basic studies or the first stages of the studies that we have been doing are already showing some results, and whenever you have a map with a red square on that, meaning that somebody may be dead after an earthquake or after an event, then you should have to do something. And with the use of part of this work that has been going on in San Jose, for example, is already shaking the minds of the engineers members of the Seismic Code Permanent Commission, and they are reviewing the code, and with this information from the basic stages of Capra and what happened in Chile, we will probably come out with a stronger seismic code, and that's an application of a mitigation measure coming from Capra.
I want to add another point. The persons trying to explain risk is quite difficult. I agree totally. It's quite difficult, but for the person it's quite simple if it hurt the pocket. I mean, if the premium rate is calculated properly, and the risk in the case of earthquake, for example, is based or is defined mainly for the same time of exposure, based on where is located the house or the building, and one particular region is most exposed to earthquake, so the rate premium should be higher in that particular part of the country than in a less exposed. So we have currently the premiums differentiated at the level of district, with this administrative division. So it's a way to person to understand that if I'm going to build a house in, I don't know, Guanacaste, the insurance company is going to charge me a higher premium than if I build a house in, I don't know, Limon, for example. So this is also a way to make a concrete expression of risk in terms of cost.
Okay, some words to end this session. Indeed, we will have a session in Spanish tomorrow in the afternoon about this type of topics. and then particularly about applications of Capra. I have other question here. What is needed to advance? Capra is a living instrument. We can imagine doctoral students, master students, researchers, professors, and many persons involved in the process to get a better modules and applications and new hazards, and so on in Capra. We expect that in 5-10 years we will have workshops about Capra and many other things. Also, I would like to thank all of you for your kind attention, but also all persons that have been involved with the forum in the internet, because certainly we have been very happy to be the participation of many of you, many that are not here, but I have been with very enthusiasm working and showing, and we expect to continue with Capra in the internet website, in the Understanding Risk. So only to say all panelists and discussants and to the World Bank this opportunity to share in very short time what is Capra, but mainly perhaps the most important is Capra is the opportunity to measure the unmeasurable. Indeed, Lord Kelvin said, for decision we need measures. So the idea is risk is very difficult, hazard is very difficult to be measured, but Capra is an opportunity, and Capra could be a way to attempt this difficult enterprise. Thank you very much for your kind attention.